Hi Algebra 2, this is Unit 8, Lesson 2.5, and today we're going to talk about extraneous roots, which we mentioned in the last lesson. So an extraneous root or solution to an equation is a root that arises from proper algebraic manipulation but fails to be a solution to the original equation. We're going to look at them again when we do Unit 10, but for right now we're going to look at why they come up when we do square root equations. So exercise 1, we just want to write each of the following radical expressions as integers. So the square root of 5 is 5. If I put a negative sign in front of it, okay, the square root of 100 is 10, but that negative sign, my answer is negative 10. Because when I do a square root, there's actually two answers. There's a positive answer and a negative answer. The square root of 9 is 3. And the negative square root of 49 is negative 7. Okay, let's begin to look at why these extraneous roots sometimes come up. So we're going to look at these two equations that are similar. X minus 2 equals the square root of x, and x minus 2 equals negative square root of x. So we're going to solve each of these. So remember, the way that I solve for x is I have to get rid of that square root, so I'm going to square that right side, but whatever you do to the right side, you have to do to the left side. So when I square the square root, that just leaves me with x, and then I'm going to do x minus 2 squared. Now that really means x minus 2 times x minus 2. So if you can do that FOIL in your head, great. It's going to give you 4 terms, but those two middle terms can be combined. So it's x squared minus 4x plus 4 equals x. Now to solve a quadratic, I have to bring everything over to one side. All right, so I'm going to get x squared minus 5x plus 4 equals 0. After I bring everything over to one side, I'm going to factor. So this is all stuff we've been practicing. And I'm looking for the factors of 4 that give me a negative 5. So if I was to multiply negative 4 times negative 1, I multiply that gives me a positive 4, but when I add the outside and the inside terms, the negative 4x and the negative 1x, that gives me that negative 5x. I take each answer and I set it equal to 0 and I solve. All right, so I'm going to get two answers, and those answers are x equals 4 and x equals 1. All right, now I need to check those answers. So I'm just going to do a quick check for when x equals 1. All right, so I'm going to plug in 1. 1 minus 2 equals the square root of 1. Well, 1 minus 2 is negative 1, and the square root of 1 is 1. So I need to reject this answer. That doesn't mean I erase it. I leave it right there, but I'm going to reject that answer. And then I want to check for when x equals 4. So again, I'm just plugging it in. 4 minus 2 equals the square root of 4. 4 minus 2 is 2. Square root of 4 is 2. Perfect. Accepts. All right, let's try the other equation, which was similar. Again, I have to square this to get that x by itself. So to undo a square root, I square it. So I have negative square root of x squared, which is going to give me x. And x minus 2 squared, we just did that on the other side, is x squared minus 4x. Plus 4, I subtract x. This is the same exact thing I did on the other side. So you can see that we're going to get those same answers that I just had. And again, I'm looking for numbers that multiply to 4, but add up to negative 5. So it's going to be negative 4 and negative 1. And I get the same answers. But this time, when I check them, we're going to have a difference. So when I check these, I'm checking x equals 1. So 1 minus 2 equals negative square root of 1. Well, 1 minus 2 is negative 1, and negative square root of 1 is negative 1. It works. So this one works. And look what's going to happen when I check for x equals 4. So 4 minus 2 equals negative square root of 4. 4 minus 2 is 2, and the negative square root of 4 is negative 2. So I need to reject that answer because that one does not work. All right, I want to show you what that looks like on a graph. All right, so y equals square root of x. Okay, this is 0, 0, 0, 0, 1, 1, square root of 4 is 2. All right, looks something like this. This is, whoops, that was supposed to be curved. Sorry about that. So this is curved like that. So this is y equals square root of x. Now y equals negative square root of x, okay, is going to be the opposite. It's going to be like this. And oops. And then the last thing I want to graph is y equals x minus 2. So y equals x minus 2 has a y-intercept of negative 2, and it has a slope of 1. It's a linear equation. So right here, negative 2 is slope of 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So you can see graphically that that line, y equals x minus 2, which is what they were both equal to. Come back up here. See how both of those were equal to x minus 2? Has the two solutions. The one graph, y equals square root of x, intersects it at 4. Right? So it intersects at 4, 2. And the other graph intersects it at 1, negative 1. All right, so they have two, depending on which equation I'm using, they have two different solutions. So what happens when I'm squaring both sides of an equation? When you square both sides of an equation, you lose whether the original expression was positive or negative. Once squared, it could be either. So that's what's resulting in these extraneous solutions. So when we square both sides of an equation, we lose whether the original expression was positive or negative. Once squared, it could be either one. So once we square it, it could be either. So all you're going to have to do when we're solving these square root equations is that you are going to have to just check your answer to see if there are any extraneous solutions. All right, so let's look at another example. So if we're looking at exercise 3 right here, and I'm going to solve it, and you're going to identify the true roots and any extraneous roots of each. So the way that I solve this is I square both sides, because by squaring it, I get rid of that radical. So on the right, I'm just left with 3x plus 19. And on the left, x plus 3 squared means x plus 3 times x plus 3. All right, and if you need to sort of do that or see it off to the side, all right, that gives me x squared plus 3x plus 3x plus 9. You can do that all in your head, combine that together, so it's x squared plus 6x plus 9. Everything needs to come to one side, so I'm going to subtract the 3x, and I'm going to subtract the 19, so everything will be on one side, and I will have x squared plus 3x minus 10. Then I have to factor each side. Factors that multiply to 10 and give me 3 as a middle term are going to be positive 5 and negative 2. So they multiply to negative 10 and they add up to positive 3. So my answers are x equals negative 5 and x equals positive 2. Now I got to do a little check. Let's plug in negative 5. Negative 5 plus 3, that goes in on the left. And the square root of 3 times negative 5 plus 19. Well, negative 5 plus 3 is negative 2. 3 times negative 15 is negative 5, 3 times negative 5 is negative 15 plus 19 is going to be 4, and the square root of 4 is positive 2. All right, so this answer does not work. I'm going to just make a single line through it. Let's check the other answer when x is 2, so 2 plus 3. on the left, and square root of 3 times 2 plus 19. So 6 plus 19 is 25, and the square root of 25 is in fact 25, so that's my answer. Okay, so that's what you're going to be doing when you solve these. And just to show you another similar equation, but this time I have a negative in front of that square root of 3x plus 19, so we just did that same thing on the other side with a different expression. So I square the right to get rid of the radical, and that leaves me with 3x plus 19, because a negative squared is a positive. I square the left, because whatever you do to the left, you have to do to the right. So I get x squared plus 6x plus 9. I'm going to subtract my 3x, subtract my 19. This should be really easy because we just did it. So I get x squared plus 3x minus 10 equals 0. Of course, it's going to be the same factors because we just did this. And my answers are negative 5 and positive 2. But now when I go to check these, right, so I'm going to check the negative 5. Negative 5 plus 3 equals negative square root of 3 times negative 5 plus 19. So on the left, I have negative 2. Negative 15 plus 19 is 4. But I have that negative sign in front of it. So you can see that this time the negative 5 works. And this time when I plug in 2, that is not going to work. Right? So this is how you're going to do these problems. You just, whenever you solve, you have to make sure that you go back and you check both answers, all right, to make sure that they are in fact solutions. So this one does not equal, so therefore that is not a solution. Okay? And then we're going to do this last problem here. Consider the equation x minus 4 equals 2. So I just want to show you that, yes, this comes up all the time when I have square root equations, but it also can come up if I have a linear equation. So if I have this linear equation, x minus 4 equals 2, there's only one solution. It's a linear equation. It should only have one solution. I solve for x by getting rid of that 4, x equals 6. Okay, linear equation should only have one solution. But what if I tried to solve this by squaring both sides first? So I'm going to square the left and I'm going to square the right. Well, on the left, that would give me x squared minus 8x plus 16. And then I got to bring that 4 over to the other side by subtracting 4. X squared minus 8x plus 12. And then when I factor this, I'm looking for the factors of 12 that give me negative 8. So if I have negative 6 and negative 2, all right, I get two solutions. So I get x equals 6 and x equals 2. Of those two solutions, which is the extraneous solution? What related equation to the original would it solve? So the extraneous solution is going to be this x equals 2 is the extraneous solution. If you go back and plug that in, it's not going to work. All right, so that's the extraneous solution. And it would solve if my equation was x minus 4 equals negative 2. That's what it would solve. Okay? And so we got one last problem here. What is the solution set of this equation? So again, how do I do that? I have to get rid of the square root, and I square that. So on the left, I have x squared. And on the right, the squaring of the square root just makes that square root disappear. Everything needs to come to one side. So I bring the 3x to the left. I bring the 40 to the left. I'm now going to factor this. So I'm looking for the factors of 40 that give me negative 3. So I have negative 8 and positive 3. So my answers are 8 and negative 5. But I have to check them. So quickly, I'm going to put 8 on the left, and I'm going to put 8 on the right and see if it checks. So 3 times 8 is 24. 24 plus 40 is 64. And yes, in fact, the square root of 64 is 8. So 8 works. Let's check negative 5. So negative 5 equals the square root of 3 times negative 5 plus 40. Well, that's negative 15 plus 40 is 25. But the square root of 25 equals 5. So this does not work. All right, so my solution is choice 2. All right, so we'll practice those tomorrow.